Hello everyone, welcome to High Tech Study Plus, and today we will be discussing chapter 11, that is Human Eye and the Colorful World, the part 1 of this chapter. So in the part 1 we will be discussing about the human eye and the power of accommodation. So first and foremost, as we have shown here, this is the diagram of the human eye. So what is the human eye? The human eye is like a camera, and the lens of the human eye, it forms an image on the light sensitive screen of the eye, that is the retina. And this light, it enters the eye through a thin membrane that is known as cornea. So this light, it enters through the cornea, and this lens forms an image on the retina, and this is the light sensitive region of the eye. Now how does this light enters into the eye? It enters through a small aperture. That aperture is known as pupil. And how is the size of this pupil regulated? It is regulated by means of two muscular structure that is known as the iris. And above all, we can see that the eyeball is like a spherical in shape, and the diameter of this eyeball is about 2.3 centimeter. So the important points that you need to remember here is that first thing is the human eye is like the camera. Second thing, that most of the refraction that occurs while the light is entering into the human eye is through the cornea. Then the lens is used for the finer adjustment of the image that is formed on the retina, is the light sensitive region of the human eye. And what is pupil? Pupil is the aperture through which the light enters into the human eye. And apart from this, there are two important parts, that there is fluid in between the lens and the cornea. This fluid is known as aqueous humor, and beyond the lens, the fluid that is present, that is known as vitreous humor. And after this, the image is formed and the sensation are carried by the optic nerve. So this is all about the human eye. Now coming to the power of accommodation. The eye lens is a fibrous jelly-like material. So this lens is like a fibrous jelly-like material, and its curvature, the curvature of the lens, how it can be modified? It can be modified by ciliary muscles. Okay, so when this lens, it can either be thin or it can be made thick. So when it is made thin, its focal length increases. So if it is made thin, what happens? Focal length, it increases. So when this focal length increases, it is used to see the distant objects clearly. Whereas when the lens is made thick, what happens? The focal length of the lens, it decreases. So by this, what happens? We can see the near objects clearly. I repeat, again, when this lens is made thin, the focal length increases, whereas when it is made thick, the focal length decreases. So when it is made thin, it is used to see distant objects, and when it is made thick, it is used to see nearby object. So the ability of the eye lens to adjust its focal length is called the accommodation. However, the focal length of the eye lens cannot be decreased beyond a certain minimum limit. So for comfortably and distinctly looking at an object, the object should be at least 25 centimeter from the eyes. Okay. This minimum distance at which the objects can be seen most distinctly without any kind of strain, it is known as the least distance of distinct vision. Least distance of distinct vision. So what is least distance of distinct vision? It is the minimum distance at which the objects can be seen most distinctly without any strain to the eyes. Okay. So it is also called as near point of the eye. Near point of the eye. Okay. For a young adult with normal vision, the near point is about 25 centimeter. Now, if we have a near point, we can also have a farthest point. The farthest point up to which the eye can see objects clearly is called far point of the eye. Far point of the eye. So what is this far point of the eye? It is the farthest point up to which the eye can see objects clearly. So sometimes the crystalline lens at old age, it becomes milky and cloudy, and this condition is known as cataract. Cataract. In this condition, the lens become milky and cloudy. So I repeat, in case of cataract, the lens becomes milky and cloudy, and this may lead to partial or complete loss of vision. But you can restore the vision. It is possible to restore the vision with the cataract surgery. How do you treat this? Treatment is by cataract surgery. Okay, that's all for the first lecture. Thank you.